Hello friends, welcome to Finavision, your one-stop solution for CFA classes. My name is Shushmit Aditya Mukherjee and this video is part of the full chapter videos taken as part of the CFA Level 1 curriculum. If you want to access more such videos, the playlist is given in the description, so please check that out. Keep watching and let's get started with this class.
So friends, today we will discuss a topic called demand and supply analysis. This belongs to CFA Level 1 economics section. Let's say a car Bolero. Let's say this is basically SUV by one of the leading automotive companies of India, and this is priced at, let's say, 8 lakhs. Let's say 1000 Boleros sell every year at a price of 8 lakhs. Now let's say after one of the years, the price increases from 8 lakhs to 10 lakhs. What do you think? What will be the number here? More than 1000 or less than 1000? It should be less than 1000, right? Ideally, it should be somewhere around 800 or 900 or something like that, right? Depending on how the GDP is performing, how the employment scenario is, etc., etc. The numbers will be ideally ranging somewhere here. Now, what does this indicate, friends? This basically indicates that price and demand have an inverse relationship. As the prices go up, demand goes down. This phenomenon is called the law of demand. This law says that the same good, which has the same utility and same value, if its price goes up, its demand should fall. This is what law of demand means. It's a simple law, friends. Now, we will add a few other factors also to it. So far we have said that demand of a particular object or a particular commodity or a particular product, let's say demand of X is the product here, is dependent only on price of X, right? Now, actually there are some other factors also which dictate this demand, not only the price of X. What are those other factors? Those other factors are income of the individuals who are buying it. Another factor can be price of a comparable object to X, let's say a price of Y. These three factors actually determine what should be the demand of X. Y is basically nothing but a comparable product with respect to X, right? So let's say if one of the products is a laptop, let's say laptop of Lenovo, we are also looking at the price of laptop of HP. And this comparison also determines what will be the demand for Lenovo. This is how demand actually works. So this is a combined function of PX income and a comparable product's price. Now the demand is basically a quantity, right? So we can write QX is a function of PX, I and PY. So it is dependent on three factors: its own price, income of the individuals buying it, and the price of a competition or a comparable product, right? So here we go. Now let's take an example of this. Let's say price of a product is $25. Price of a comparable product is $30. And income of the individuals buying it is $100,000 annually. Now the relationship between demand and PX, PY and I are given like this. QX is equal to minus 5 into PX plus 0.025 into I, that is income, annual income, minus 7.5 PY. Now the demand, that is the annual demand QX, we can easily find out from the price of the two products and the annual income of the individuals buying it. So this becomes minus 5 into PX, which is minus 125, plus 0.025 into I, which is 2500, minus 7.5 into PY, which is 225. The net result comes to be This is 300, 350. So the answer is 2500 minus 350, which is 2150. So the annual quantity bought for the product X is equal to 2150. Now friends, here you can see we have used minus 5 and minus 7.5 with respect to measurement of QX, right? Why? Because naturally we are assuming that the law of demand holds. That is, if the price increases, the demand falls. The law of demand holds. This is what we are assuming, and generally for most of the products this is the case. Now friends, if you want to draw a graph which assumes that the relationship between demand and the price of the product is linear, how will it look like? Let's draw it. So friends, let's say the vertical axis represents price and the horizontal axis represents quantity. Price of X, quantity of X. So friends, as the price goes up, the demand should fall. And as the demand goes up, the price should fall. If the relation is assumed to be linear, simply linear, then it should look something like this. Right friends? This line should look something like this. And this slant of the line is basically change of P with respect to change of Q. So the slant or the slope of this line is equal to change of price with respect to change of demand. Right friends? Now friends, let us derive a very important expression with respect to the demand. Now friends, let us try and derive a very important expression with respect to the relationship between price and demand. So let us take any point on this line. Let's say we have taken this point. Now here we have three information. One is, we know what is the P value, right? The P value is here. We know what is the Q value. The Q value is down on the horizontal axis. And we also know the slope, which is constant because this is a straight line, right? This is a straight line, so the slope is constant. So we have these three informations. Let's call this point K. So if we take the ratio price by quantity at point K, that is Pk by Qk, and we divide this ratio by the slope, what we get is elasticity at point K. This expression is basically termed as the elasticity. If we choose a particular point, it is the elasticity at that particular point. And if we generalize it, then elasticity becomes P by Q ratio divided by the slope. Now if we modify the equation a little bit, then this becomes P by Q divided by del P by del Q, right? If we modify it further, this becomes del Q by Q divided by del P by P, or we can say elasticity is the ratio between the percentage change in quantity divided by the percentage change in price. Percentage change in quantity divided by percentage change in price. So this is the definition of elasticity, friends. Why we are calling this percentage change of quantity divided by percentage change of price, friends? Because when we measure del Q by Q, we get nothing but the percentage change in Q, and when we divide del P by P, what we get is nothing but the percentage change in price, if you look at it closely, right? That's why we say elasticity is basically the ratio between the percentage change in Q divided by the percentage change in price, not the change in Q by change in price. That is the slope, friends. That is the slope. You have to remember, this might sound a little confusing at start, but you have to understand this, that we are talking about the percentage changes, that is the change in P compared with the initial P, and the change in P compared with the initial, and the change in Q compared with the initial Q. So these things we have to keep in mind while we are talking about elasticity, friends. Now friends, we will talk about a few terms. Unit elastic. What do you mean by unit elastic? So let's say at a particular point in this line, let's say at this point O, the percentage change in Q and the percentage change in P become the same. What do we mean by that? Basically, what we mean is, let's say at a certain point here, let's say this is O. At this point, what happens is P by Q at O becomes equal to slope. P by Q at O becomes equal to slope. What does this mean? This means elasticity, which you can also write as P by Q by slope. Because these two are equal, this value becomes equal to 1. Unit elastic means that point where P by Q becomes equal to slope. This in turn also means that percentage change in Q becomes equal to percentage change in P. This basically in turn means that percentage change in Q by percentage change in P becomes equal to 1. This is nothing but elasticity, friends. So to simply define, unit elastic means a point or a product and price combination where the elasticity has become equal to 1. So unit elastic means a point on the price demand curve, or in this case line, or a particular price demand combination of a particular product where elasticity becomes equal to 1. Again, I'll repeat, unit elastic means a point on the price demand curve or a particular price demand combination of a particular product where elasticity becomes equal to 1. So this is what we mean by unit elastic. So essentially speaking, this is not about a particular product, friends. It's not that a particular product is unit elastic. It generally doesn't happen that way. It's more often a single point on the price demand curve of a product. Like in this case, we have assumed that O is that point where the P by Q ratio becomes equal to the slope, which in turn means the percentage change in Q at point O becomes equal to percentage change in P. So this is what we mean by unit elastic. Now, naturally, there are two other terms called inelastic. Now, there are two more terms which we'll learn now, which are elastic and inelastic. So friends, let's understand what these two terms mean. So friends, let us draw another price and demand curve, linear one, where the vertical axis again represents the price and the horizontal demand represents the quantity or the demand. And this time we are going to assume that the slope of the line is 45 degrees. And we have drawn this price demand curve here, friends. So friends, let's say in this curve there is a point M where elasticity becomes equal to 1. Elasticity at M becomes equal to 1, which basically means P by Q divided by the slope of the line becomes equal to 1, or percentage change in Q by percentage change in P becomes equal to 1. Right? So this is what is meant by this point. Now friends, let's take a point here and let us call this point E. Now friends, here there are certain characteristics that we have to observe. Here the price has increased, right? Here the price has gone up. It is higher than the price of point M, and the quantity has come down. The quantity is somewhere here. So the quantity has come down. So in effect, P by Q at point E has increased with respect to P by Q at point M. But the slope is constant. Slope of the entire line, because this is a straight line we have assumed, the slope is constant. So this means elasticity at point E has become greater than 1. Elasticity at point E is equal to P by Q at point E by slope. This basically means this is greater than elasticity of M, or elasticity at point M. Now, this means elasticity at E is greater than 1. And any point if you take above M here, any point, if you take this point, if you take this point, if you take this point, everywhere the price increases and the Q drops. Therefore, the P by Q ratio increases, which means elasticity increases above 1. So this entire range, if you say so, this entire range above this point M is basically the zone where elasticity is greater than 1. And this kind of range is basically called the elastic range. And in this kind of range, we say that the product is elastic. Wherever elasticity is greater than 1, that is in this range that we have marked with the second bracket here, we say that the product is elastic. Now what about inelastic? Let's check that also, friends. Let's take any point below M on the line. Let's say here we take a point. Let us call this point I. Now here you can clearly see that the quantity has increased. The quantity is increased from the point M, and compared to point M the price has gone down. So here obviously the P by Q ratio at point I becomes less than P by Q ratio at point M. But the slope remains constant at this point also, which means that here elasticity is less than 1. That is, elasticity at point I is less than 1. Now instead of point I, if you take any point below M, if you take this point, same thing happens. The P by Q ratio falls below the P by Q ratio of point M, which means elasticity remains less than 1. That means any point in this kind of a range here, the product is inelastic. So when elasticity is less than 1, we say that the product is inelastic. Right, friends? So we have understood basically. So friends, from this deduction we can understand that if a point lies above the point M on the price demand curve, it is an elastic point, or the point is a point of elasticity, and any point below it is a point of inelasticity, right? So these are the ranges of elasticity and these are the ranges of inelasticity. So let us write the postulates here. So friends, any point on the price demand curve or line above the point of unit elasticity represents a point of elasticity. Above the point of unit elasticity represents a point of elasticity. And on the other hand, any point on the price demand curve below the point of unit elasticity represents a point of inelasticity. So below unit elasticity means inelasticity, above unit elasticity means elasticity. And elasticity generally means the elasticity value is greater than 1. Inelasticity means the elasticity value is less than 1. And in between them, the perfect point is unit elasticity. Perfectly elastic and perfectly inelastic. What do we mean by these two terms? Let's understand, friends. Let's draw another price demand line or price demand curve. This time we'll make it a little different, friends, and understand what is the meaning of this difference. Now friends, let's say at a certain price Pi, the price quantity curve becomes horizontal like this. Now what does this signify, friends? This generally means a slight upward movement can drastically change the demand. So this kind of situation where slight movement drastically changes the demand, this kind of scenario is called a perfectly elastic state. This is generally happening in a very commoditized market. Commoditized market means, let's say the market of wheat or apples. Let's say the market of wheat. Now, Joe's wheat and Jack's wheat, these are two separate shops. Now between these two shops, product differentiation is very difficult, friends. For a product like wheat, differentiation is very difficult. So if Joe is slightly higher in price, the entire consumption may shift to Jack's wheat. If Jack shifts the price slightly higher, then the entire demand can move to Joe's wheat. This is how this kind of a scenario of perfect elasticity can happen, that somebody changes the price just a little bit upward or downward and gets a bulk of the demand towards or against him or her. This kind of a scenario is called perfectly elastic state. Now friends, let us talk about something called income elasticity. Now friends, we understood price elasticity of a product, let's say X, is given by percentage change in quantity with percentage change in price. Right? Now, what do you mean by income elasticity, friends? Let's say the market which is buying a product has an average income of I. Now, the elasticity with respect to income is equal to percentage change in quantity of the product divided by percentage change in the income. This is equal to change in quantity by initial quantity whole divided by change in income by initial income. So this is what we mean by income elasticity. Now friends, generally elasticity of price is negative. Right? That is, if the price increases, the demand falls. So the relationship is negative, inverse. But in case of income, friends, it can be everything. It can be positive, it can be negative, it can be zero also. Now, if income elasticity is positive, the product which is being bought here is called a normal good. That is, if income increases, then demand also increases. If the income elasticity is negative, then that kind of product which has a negative income elasticity is called a inferior good. That is, if income increases, the demand for that kind of a product falls. So for an inferior good, rise in income leads to fall in demand. For a normal good, a rise in income leads to increase in demand. Right, friends? Now, how does the curve behave? So let's say this is the curve, price to demand curve of a normal good. Now, if the income increases, this is the initial income, right? Initial income, right? Now, let's say the income increases. Then what happens, friends? If the good is a normal good, the curve becomes something like this. So it moves to the right. It moves this side. This is for a normal good. If the income increases, the entire demand curve shifts to the right. That is for the same price. Let's say the price is here. The initial demand was here. Now it has increased to here. So the demand increases, the entire curve shifts to the right. And if it's an inferior good, what happens? In this case, the curve moves here. That is, let's say for the same price, the demand was initially here. Now it moves to the left, that is, it decreases. The entire curves move to the left. This is for an inferior good. Right, friends? So we have defined normal good and inferior good through this illustration. Now we'll talk about something called substitute price elasticity. Let's say there is a product X. Its price elasticity will be given like this. Elasticity of X is equal to percentage change of quantity of X divided by the percentage change in the price of X. Now what do you mean by the substitute price elasticity? Let's say there is a substitute of X which is Y. Y is a substitute. Now, elasticity of X with respect to substitute Y is given by percentage change in quantity of X divided by percentage change in price of Y. So when the price of the substitute changes, how much does the demand of the product in question change? That is, when substitute Y changes the price, how much does the quantity of X changes in terms of sales? This is what substitute price elasticity means. Now, this also can be positive or negative. Right, friends? So, if elasticity of X with respect to substitute Y is positive, then these two products X and Y are substitutes. That means if price of Y goes up, then people buy less of Y and more of X, that is Q of X also goes up. Or if price of Y goes down, that is when Y's price comes down, people buy less of X, that is Q of X also comes down. Right? These are called substitutes. And when the substitute price elasticity of X with respect to Y is negative, then X and Y are said to be complementaries. For example, car and car insurance, or cars and fuel. If the price of cars goes up, then the sales of car falls, which means consumption of fuel also falls. That is, P of Y goes up and Q of X comes down. This kind of a scenario is called a complementary scenario. Or if the price of cars come down, obviously more cars are sold, that is sales go up, which means fuel is also consumed more, right? So price of car comes down, fuel consumption or quantity of fuel goes up, which means P of Y goes up, Q of X comes down. This kind of a scenario is called a complementary product scenario. These two products are complementary. It can also be house and interior designs, house and interiors, right? So like this, friends. For normal substitute, the examples are pretty easy, friends. Like, let's say company A sells a soap at PA. You buy this product. Now, a same quality soap is being introduced by company B at a price PB which is less than PA, right? PB is less than PA. In that case, what will happen, friends? obviously you will buy more of B and less of A. So Q of A will come down. So if P of B comes down, Q of A also comes down. So this is a direct relationship. So this is all about the elasticity of substitute prices, friends. Let's say there is a product X, friends, and it is a normal good. It is a normal good and its demand right now is QNX, right? Now we want to understand what is the impact of substitution effect and income effect on this product. So if PY, that is the price of its substitute goes up, then QNX goes up. That is, people buy more of X if it's a normal good. What happens if income goes up, friends? If income goes up, then also its quantity or its demand goes up. Now let's say this product X is not a normal good, it is an inferior good, friends. And its demand is QIX. Now what happens with substitution effect and income effect, friends? Let's understand. So in case of QIX, if price of Y increases, that is the price of the substitute increases, people still buy more of it. So the substitution effect is still positive. But if income goes up, people will buy less of it. They will buy something more superior to this product. So this is the combined impact of substitution and income on a normal good and an inferior good. So all the effects are positive. All the effects are positive except one, except the income effect on the inferior good. Income effect on the inferior good is negative, rest all are positive. So you can just remember this, income effect on inferior good is negative. Rest all relations, inferior good, substitution effect, normal good, substitution effect, normal good, income effect, all these are positive. Giffen goods and Veblen goods. What are these, friends? Let's first discuss Giffen goods. Giffen goods are basically inferior goods whose income effect is stronger than substitution effect. Giffen goods are inferior goods whose income effect is stronger than substitution effect. What do we mean by this, friends? Basically, let's say there is a product X which is a Giffen good. That means that if price of its substitute goes up by 5% and income of the buyers also goes up by 5%, combining these two situations, the demand of X will still fall. Right? Because why? Because price of Y changes and this causes increase in QX, right? But income rise decreases the QX and this one is stronger. Therefore, as a net effect, QX goes down. That means rise in income reduces the demand much more than does the increase in demand due to increase in price of the substitute. Right? I'll repeat once again. X is a product which is an inferior product, and if the income rises by 5% and substitute price also rises by 5%, then technically QX should not change. Demand for X should not change because price of a substitute has gone up by 5%, but income has also gone up by 5%. So demand should remain the same. But in this case, demand falls because income effect is stronger than substitution effect. Now, what are Veblen goods? Veblen goods are those goods whose price tag itself creates an appeal, creates a status appeal or a lifestyle appeal that increases the consumption. That is, if its price tag goes up, technically its quantity should go down, but it does not go down, it also goes up. So price elasticity is positive. An example can be an Armani suit. it is basically the high prices. It is basically the high prices that creates that status symbol, right? Status symbol or a lifestyle symbol, which in turns creates the demand. Which in turns create the demand. Demand for Armani suits. This kind of a good is called a Veblen good. So let me define it. A Veblen good is a good whose own price elasticity is positive. That is, if you put a higher price tag, the demand tends to go up instead of coming down. So this is what a Veblen good is. So we have discussed Giffen goods and Veblen goods. Marginal return and productivity. Let's first discuss what is productivity, friends. Now friends, let's say a factory is producing Q quantity of a certain product in a year, right? Now this is being accomplished by L labor hours and K machine hours. Now what do we mean by labor hours and machine hours, friends? Let's say there are 3 machines which are working for 12 hours each day, and they are working for 300 days in a year. So the total machine hours in this case is K is equal to 36 into 300, that is 10800 hours. This is the amount of K, right? And let's say there are 20 laborers working for 8 hours a day for 300 days in a year. So the number of labor hours is equal to 20 into 8 into 300, which is equal to 160, 48,000. So 10,800 labor hours and 10,800 machine hours and 48,000 labor hours are accomplishing the quantity Q productivity every year, right? Therefore, productivity given by the quantity of product is equal to a function of K and L, right? If either of them or both of them change, then the productivity is also going to change, right? For example, if K goes down, everything else being constant, productivity will come down. Or if L comes down, everything else being constant, again the productivity will come down. Or if K and L both come down together, then obviously Q will come down. So this is what we mean by productivity. Productivity is basically the output that is being created by the labor and the machine. That is, productivity is basically the output that is being arrived at from the given inputs. In this case, the inputs are labor and machine hours. Now, in terms of productivity, there are 3 kinds of terms. One is total productivity, one is average productivity, and one is marginal productivity. Let's discuss these terms. Let's say NL number of laborers work for L labor hours in total to give productivity of Q. Now let's say we give ranges to it. When there are 2 laborers, they work for 20 labor hours every day and produce a quantity of 30. When there are 5 laborers, they work for 45 hours a day and they give a productivity of 60. When there are 10 laborers, they work for 80 hours a day and give a productivity of 100. Now, we want to find out when the labor count is 10, what is the total productivity? What is the total productivity for 10 laborers? What is the average productivity for 10 laborers? And what is the marginal productivity for 10 laborers? That is, when the number increases from 5 to 10, what is the productivity increase, right? So let's find it out. So total productivity when number of laborers is 10 is nothing but 100, right? And to get the average productivity is nothing but the total productivity divided by the number of laborers. Total productivity divided by the number of laborers. This is equal to 100 by 10. This is equal to 10. And what is the marginal productivity, friends? Marginal productivity when NL is equal to 10 is nothing but the productivity of the last 5 labors. That is, after increasing the number of labors from 5 to 10, these last 5 labors that you have added, what has been the productivity of these last 5 additions? This is the marginal productivity at NL is equal to 10. So this is given by total productivity at 10 minus total productivity at 5 divided by 10 minus 5. This is equal to 100 minus 60 divided by 10 minus 5. This is equal to 40 by 5 or is equal to 8. So the 5 additional labors that you have added after 5 labors has given you 8 units of productivity each. Right? So we can now define what is the total productivity, what is the average productivity, and what is marginal productivity, right? So it is easy to understand what is total productivity and average productivity. Marginal productivity is basically the productivity you are getting out of the last lot of input additions. The last lot of input addition. In this example, it is increment from 5 to 10. Right? It could be anything. In the charts mentioned, if you are given a question, it could be given like there are 2 labors, this is the productivity 10. If there are 3 labors, productivity is 15. If there are 5 labors, the productivity is 20. The question may be, find out the marginal productivity for 3 labors. Marginal productivity for 3 labors. What will this be? This will basically be total productivity for 3 labors minus total productivity for 2 labors divided by 3 minus 2. This is equal to 15 minus 10 divided by 1 or 5. Again, the question can be, find out the marginal productivity for 5 labors. So, marginal productivity for 5 labors will be given by total productivity at 5 labors minus total productivity at 3 labors divided by 5 minus 3. This is equal to 20 minus 15 divided by 2. This is equal to 2.5. So this is how the marginal productivity has to be taken out, friends. I hope this section clarifies the marginal productivity, which seems to be a little tricky, but it is actually not at all. It is very easy concept to understand. Now friends, let us try to understand the concept of marginal return and cost. Let's first understand the concept of marginal returns. So friends, let's say there is a Tesla gigafactory which has the capacity of producing 1 million cars in a year. Right? 1 million cars in a year. Now, right now it is producing 600,000 cars. Right now it is producing 600,000 cars. And the number of labors it is using is, let's say, 9,000. Okay? The number of labors it is using is 9,000. Now let's say it wants to fully utilize the capacity of the plant. So it increases the labors. It increases it to 10,000. Right? And the productivity becomes 800,000 cars. Now the full capacity is not yet reached. So the number of labors is increased further. It is increased to 15,000. This is the final count. It is increased to 12,000. At that point, Tesla is generating 900,000 cars. Still the full capacity is not reached, so the number of labors have to be increased further. And they find out it takes 15,000 labors to produce the entire 1 million cars. Right, friends? Now here we see there is a question of marginal returns. Right? Now, what are we trying to understand here, friends? Now let's say we are trying to count the average productivity of labor when the count of labor is 9,000. This will be given by 600,000 divided by 9,000. This is equal to 600,000 divided by 66.67, right? 66.67 is the productivity of labor when the count of labor is 9,000. Now, we want to find out the marginal productivity. The marginal productivity at a labor count of 10,000. Let's see what that is. Marginal productivity at 10,000, this is equal to total productivity at 10,000, which is 800K, minus total productivity at 9,000, which is 6,000K, divided by 10,000 minus 9,000, which is 1,000. This is equal to 200K divided by 1,000. This is equal to 200. Now let us find out the marginal productivity at 12,000 labors. This is equal to 900K minus 800K divided by 2,000, because 12,000 minus 10,000 is 2,000 and 900K minus 800K is 100K. So this is equal to 50. Right friends, this is 50. Marginal productivity at 15,000 laborers. This is equal to 1 million minus 900K divided by 3,000. This is equal to 33.3. Now friends, we are in a position to understand what are the marginal returns. So friends, when Tesla increased the number of laborers from 9,000 to 10,000, the marginal productivity increased 66.67 to 200, right? But something different happened when the numbers were increased from 10,000 to 12,000, friends. You can see when the numbers increased from 10,000 to 12,000, the marginal productivity of these additional 2,000 laborers was 50. So there was decrease in marginal productivity. And there was further decrease in marginal productivity when the numbers were increased to 15,000 laborers, friends. It went down to 33.3. So the last 3,000 laborers that were added had a productivity of 33.3 units. So this was half the initial numbers, right? So there was decrease. So at MP10, that is at 10,000, there was marginal increase in productivity, but then there was decline. So friends, from 9,000 to 10,000, the phenomenon that we saw was increasing marginal returns because the marginal productivity has increased. Then there was a phenomenon of decreasing marginal returns because in the second chunk there was decrease and in the third there was further decrease. So these were decreasing marginal returns. And this first phase was a phase of increasing marginal returns. So now we can define marginal returns as marginal returns is the change in productivity or returns due to marginal change in inputs. Marginal change in input means the last set of change in inputs that you have made, what is the output you are getting out of it. That is what basically is meant by marginal returns or marginal productivity or marginal product. So when this marginal productivity increases, we say there is increasing marginal returns, and when there is decrease, we say there is decreasing marginal returns. Now friends, let's discuss the concept of total cost. Let's say for output Q, we are using machine hours K and labor hours of L. Let's say the cost of machine per hour is R and the cost of labor per hour is W. Then the total cost is given by R into K plus W into L. This is the total cost, friends. Now let's say the labor wage has increased. In this scenario, if you want to keep the total cost unchanged, then productivity will go down. Because if W goes up, to keep the total cost constant, we'll have to reduce the labor hours. And if labor hours reduces, then productivity will come down. This is the relationship between productivity and cost. Or for example, let's say the cost of running the machine goes up. Now, if we want to keep the total cost constant, then we have to compromise again on the productivity. Because if R goes up, to keep the total cost constant, we'll have to put the number of machine hours down. That is, we have to run the machine less, which will mean productivity will come down. Now friends, we'll learn about a few terms: economic cost, accounting cost, economic profit, accounting profit. What do you mean by these terms? Let's start with economic cost. Let's say when we wanted to start the business, we had an option of starting business A and starting business B. We chose business A. In this case, economic cost is the cost that we let go of to avail the opportunity that we chose. So in this case, the economic cost is total cost that would have been our cost in case we chose business B, right? We chose A because we thought that is the best option. But our opportunity cost is, our economic cost or opportunity cost is the cost that we would have incurred had we chose the other option, the other alternative, the second alternative. That is what economic cost or total cost is, simply speaking. So let us define it. Economic cost or opportunity cost is the cost incursion that we let go of. The cost incursion that we let go of to avail the current choice of project or business. So we had multiple options. Among them, we let go of some option and we chose some option. The option that we let go is what creates the economic cost, right? Accounting cost. Accounting cost is directly the cost that we are incurring by virtue of the current project of business. That is, if we had two choices, business A and business B, and we chose business A, the total cost that we are incurring due to business A is the accounting cost. Accounting cost is the current actual cost that we are incurring for the current choice of project, business or inputs, right? Let me write inputs also here. Let's say we had a choice between 1000 laborers and 1100 laborers. We chose to go with 1100 laborers. Therefore, we let go of the 1000 labor option that we had. So this becomes our opportunity cost. So this is also a way to define economic cost, right? Inputs can also be included in that. Accounting cost. Again, I'll repeat accounting cost. Accounting cost is the current actual cost that we are incurring for the current choice of project, business or inputs. So in the previous example, we said that we went with the 1100 labor example. So the cost that we are incurring to employ 1100 laborers is our accounting cost, right? And the choice that we let go, that is 1000 labor option, that is our opportunity cost or economic cost. It's better to call it opportunity cost because we let go of that opportunity. It gives a better recall, direct understanding of it. Economic profit. This is equal to revenue minus economic cost. Accounting profit. This is equal to revenue minus accounting cost. So economic cost and accounting cost. This is the difference between economic profit and accounting profit. Marginal revenue. Marginal revenue is the change in the revenue due to addition of one more unit of output. Marginal revenue is the change in revenue due to the addition of one more unit of output. So this is given by marginal revenue is equal to change in revenue due to change in the number of units of output. This is equal to, you can say, del price into number of outputs, price into number of units divided by change in number of units. If you do a differentiation on it, this becomes dpq by dq. This is equal to p dq by dq plus q dp dq. Finally, this expression becomes like this. This dq dq cuts. So this becomes p plus q into dp dq, or we can write del p by del q.
Do you have doubts which you want to get clarified one-on-one? Doubt clearing sessions, mock tests, full curriculum related support, and counseling sessions. We have a bunch of enrollment options at Finavision. Do check out the link in the description and in the comment section below. Thank you so much, friends, for being with me in this video. If this video added value to you, do consider liking and subscribe to the channel. If you think that this video can be of help for someone else, do share it with them and do share your own feedback in the comment section. Till then, keep watching the videos on Finavision YouTube channel. Thank you so much once again.